Hey everyone, welcome. I'm so thrilled you're here for this explainer. Today, we're unpacking one of the absolute coolest stories in human history, literally how electricity first conquered distance. I mean, for basically all of human existence, if you wanted to send a message, you were stuck with the physical limits of the world. But then, a seemingly simple wire learned to talk, and it changed the whole shebang. Let's get right into it. Okay, let's dive into this, because to really appreciate this invention, we've got to wrap our heads around the incredibly high stakes back then. Think about it. Before this technology, sending a message from one city to another was totally limited by physical transportation. It basically depended on how fast a horse could run, or maybe how far a signal fire could be seen. A simple letter, that could take days, or even weeks to get where it was going. The speed of information was literally just the speed of travel. But electricity? Oh man, electricity promised something entirely different. It promised to shrink that massive, weeks-long distance into a matter of mere seconds. No way, right?
And the crazy part is, this transformation didn't take centuries. It happened with just breathtaking speed. Looking at the timeline, we start with a basic scientific discovery in 1820. Just a little over a decade later, in 1832, the conceptual seeds are planted. Bam! By 1844, the very first official message is sent. And get this, by 1866, we're already communicating across entire oceans. In less than 50 years, the world went from the speed of a galloping horse to instant intercontinental communication. Let's break down exactly how this happened, starting right here at the very beginning, in 1820.
So the whole story really kicks off with basic science, specifically a massive breakthrough by a Danish physicist named Hans Christian Oersted. Back in 1820, Oersted discovered something that, seems pretty simple to us now, but was absolutely mind-blowing at the time. An electric current flowing through a wire could actually deflect a nearby compass needle. This was a huge revelation. It basically proved that electricity and magnetism were deeply physically connected. And more importantly for us, scientists realized that if a pulse of electricity could physically move a needle from far away, well then, in principle, that electrical pulse could be used to carry information. Now, you might be wondering who actually took this scientific theory and turned it into a global network. You'd probably guess a brilliant engineer or, I don't know, a seasoned physicist, right? Well, actually, scratch that. The unlikely protagonist of our story is an American named Samuel Morse. And Morse was a painter, a really successful one too. He taught art and painted portraits of statesmen. But in 1832, while he was sailing home from Europe on a ship, Morse got into this deep conversation with a fellow passenger about those recent experiments with electromagnetism. The idea that a signal could travel instantly through a wire, it completely obsessed him. The idea just spread like wildfire in his brain. By the time that ship docked, this art teacher was already sketching out ideas for a device to send messages using electricity. But Morse didn't do it alone. In fact, he really couldn't have. He spent the next several years developing his system. But the real breakthrough came when he partnered with a machinist and businessman named Alfred Vail. Vail's contributions were just absolutely crucial. He was the one who took Morse's rough theoretical sketches and helped refine the actual mechanical design of the telegraph. But honestly, perhaps Vail's most significant contribution was working directly with Morse to design the ingenious code itself. The code that would allow this system to send full complex messages over just a single wire, using only one simple signal, on or off, current or no current. Now, what's really interesting about this slide is how they actually approached designing that code. They didn't just assign random signals to random letters. No, Morse and Vail were incredibly strategic about it. They actually studied the English language to see which letters were used most frequently. They figured out pretty quickly that letters like E and T are used constantly, right? While letters like Q and Z are barely used at all. They used this data to optimize their entire signaling system, making sure that the most common letters would take the absolute least amount of time to transmit. And this brilliantly illustrates the core genius of what we now call Morse code. Because E is one of the most frequently used letters, they assigned it the simplest, shortest possible code, just a single dot. The letter T got a single dash. But those rarely used letters like Q and Z, they were given much longer, way more complex combinations of dots and dashes. By assigning the shortest codes to the most common letters, Morse and Vail made sure that on average, entire messages could be sent significantly faster. It was, quite literally, a masterpiece of early data compression. So how did the machine actually work? Well, it's remarkably elegant, operating on a really simple electrical circuit. First, the operator presses down on a telegraph key, which, by the way, is essentially just a switch, to complete the circuit. Second, this sends a pulse of electricity traveling down a wire, which could stretch for miles and miles. Third, at the receiving station, that electrical current activates an electromagnet, which pulls down a little metal armature. And finally, in the earliest versions of the system, that armature caused a stylus to physically tap out marks, those dots and dashes, right onto a moving strip of paper.
But here is a truly fascinating detail about human adaptation. Originally, operators were supposed to look at that strip of paper and translate the physical marks back into letters. But over time, operators evolved. They realized they didn't even need to look at the paper. They learned to simply listen. By paying close attention to the rhythmic clicking sounds of the receiver's armature hitting the metal, they could translate the complex patterns of clicks directly into words, just by ear. The wire wasn't just making marks anymore. To these trained operators, it was literally speaking a language of sound.
After years of struggling to get funding and facing just a ton of setbacks, Morse finally convinced the U.S. Congress to fund an experimental line between Washington, D.C. and Baltimore. And on May 24, 1844, he sat down and tapped out the line's very first official message. A friend had actually suggested a simple phrase, "What have God wrought?" Within seconds, dot for dot and dash for dash, that exact message appeared 40 miles away in Baltimore. It was a stunning demonstration. An hours-long journey by horse and rider had just been completed almost instantly. The world would for sure never be the same. Following that success, the impact was absolutely explosive. Telegraph companies raced to string wires between cities, states, and eventually entire countries, creating what basically became the global nervous system of the industrial world. I mean, it transformed society overnight. Newspapers could suddenly receive and print same-day news from distant cities, which completely revolutionized journalism. Railroads used the telegraph to coordinate schedules in real time, allowing stations to warn each other about oncoming trains and drastically reducing collisions on shared tracks. And businesses, they could instantly send prices, financial information, and orders across the country, fundamentally reshaping how commerce worked. The biggest technical challenge left was crossing the ocean. They first succeeded in laying a transatlantic cable across the ocean floor in 1858. But, unfortunately, it was a technical failure. After only a few weeks, the electrical insulation degraded, the signal got way too weak, and it just died. But engineers didn't give up. By 1866, after several more attempts, they successfully laid a reliable transatlantic cable. This was a miraculous achievement. For the very first time in human history, a message could travel between continents in a matter of minutes. Instead of the roughly 10 days it took by ship, the continents were finally connected. Let's move to and see how this builds into the technologies we recognize today. You see, the telegraph remained the fastest form of long-distance communication for the better part of a century. But eventually, this revolutionary network was surpassed. It was gradually replaced by the telephone, which allowed people to speak directly using their actual voices rather than tapping out coded messages. And later, it was eclipsed by the radio, which removed the need for physical wires entirely. The technology moved on, but the foundation had been permanently laid. So the crucial point is that even though the telegraph machines themselves faded from everyday use, Morse code certainly did not disappear. It survived because it was incredibly resilient. In fields where signals needed to get through despite weak reception or just incredibly noisy conditions, a simple series of dots and dashes could often be understood when a voice transmission simply failed. It became the standard for ships, aircraft, and the military for much of the 20th century. And the most famous example? The distress signal SOS. 3 dots, 3 dashes, 3 dots. It was chosen specifically because it is elegantly simple, highly distinct, and absolutely impossible to mistake for anything else. Which brings us to a final provocative thought to wrap up our explainer today. What started as an art teacher's curiosity about a deflecting compass needle grew into a massive system that connected the entire globe. The telegraph was built on the elegantly simple idea that complex human language could be broken down into short and long electrical pulses, current on or current off, and sent down a single line. So I leave you with this. If a 19th century wire laid the groundwork with those simple on and off pulses, aren't our modern digital networks, which run entirely on binary ones and zeros, really just billions of dots and dashes in disguise? It's pretty amazing to think that the legacy of Samuel Morse and Alfred Vail is still pulsing through our world today. Thank you so much for joining me to explore this fascinating topic. Keep learning, and I'll catch you next time.